Hello, everyone, and thank you for joining our online discussion today. Today we'll be talking about drones and drone technologies in academic and scientific research, and mainly in hydrology. And we have a lot of beautiful and very, I would say, experienced guests today. Dr. Narcisa Pricope, Associate Vice President for Research at Mississippi State University. Narcisa has a huge experience, extensive experience with drones and everything about geospatial intelligence and bringing up new drone pilots and students. And she was a founder and president of University of North Carolina, Wilmington Geospatial Laboratory. Also, she was a founder of Coastal UAS Observatory. So sometimes I hear Narcisa calls herself a drone girl, and I would support that. And yeah, thank you, Narcisa, for joining. That's really a great honor to have you here today. And as a second guest today is a Professor Peter Bauer-Gottwein from Technical University of Denmark. Peter is a professor in Department of Environmental and Resource Engineering, and he's an expert in hydrology and in water resource management, and he knows a lot about different sensors and how they can be used for monitoring river response, whatever, and how to put all these technologies into research. Thank you, Peter. That's a great pleasure to have you here today. A bit about housekeeping. You can see all you as our listeners have this Q&A feature. So if you have any questions, comments, or ideas to share, please use this Q&A section. Also, if you want to participate in our discussion and to share your experience, your insights, your ideas, please raise your hand. And if you have time, we'll let you participate in this discussion. And the recording of this webinar and this panel discussion will be available in a week, and we put it on our YouTube channel. So please subscribe and please follow our YouTube channel of SPH Engineering. And what else? And yeah, have fun today. And I believe and I hope that you'll have a lot of useful information, a lot of great insights, and that will help you to boost your scientific research, boost your academic projects, and to do them in a more efficient and more sustainable way. And we'll start with a short presentation from Narcisa about their efforts and their projects. So, Narcisa, the floor is yours.
Yeah, okay. All right. So good morning, everybody. Good afternoon, wherever you're at. Thank you so much for joining us today for this discussion. And thank you to SPH Engineering and my colleagues for the invitation to talk about how we are using drones in coastal research, training, and specifically workforce development. I see these components going hand in hand in advancing not only what we do with drones and research, but also enabling the future generation of technicians and scientists and participants in the workforce to thrive and bring all of these amazing skill sets and all of this amazing technology to bear to better us as a society overall. So I want to talk about coastal systems, and when we think about coastal systems, and when we think about the latest estimates from the Population Reference Bureau that say that about 50% of the world's population lives within 200 kilometers of a coastline, and that in the next few years that figure is likely to double. that brings home the message that coastal ecosystems play a critical role, not only in maintaining just global biodiversity and ecosystem services, but really in our livelihoods and in the future adaptation of coastal regions and the world's half of the world's populations to climate change and variability. So these ecosystems um, are essentially the nexus between biodiversity, climate, and sustainable development and the continuation of our livelihoods as we know it. And so they are considered blue carbon wetlands specifically are considered blue carbon ecosystems, and that simply means that the carbon captured by living organisms throughout coastal and marine environments, stored in ecosystems as well as in biomass and sediments, really make up a big part of how we can not only adapt but also start thinking more about mitigating the impacts of climate change. So coastal ecosystems are critical, and that's the tie into hydrology, and that's the angle that I've been working on for a few years in my previous institution and hoping to continue where I'm at right now. But how did I get into drones to do coastal research, and why did I start using drones? I really the way I got into drones, and I consider them in a way a gateway to remote sensing and a gateway to geospatial sciences and geospatial engineering, because and they are a gateway in the sense that they provide us with technology that can be used across so many different aspects, but in a relatively straightforward and simple way. And I got into drones specifically because they fill a gap. They fill a gap between the data we get from satellites, the data we get from various other types of airborne platforms, and the data we get in situ, boots on the ground. And if you work in coastal research, you know that boots on the ground is difficult to accomplish. It's hard to trample through sensitive wetland ecosystems and do transects and collect data. So I saw drones as an important gap filler in the beginning when I got into this kind of work back in 2016 timeframe, when drones weren't exactly as sexy as they are now. But they do have a lot of trade-offs between spatial extent and coverage, temporal spatial resolution, accessibility, payloads, cost, all of these kinds of things that we're hoping we're going to tease out a little bit more today. So that's why I got into drones, because they fill the gap between what we can get on the ground and what we get from space or from other airborne platforms in a really beautiful way. And I'll give you some examples. And as I said, a lot of my work, it's always been with the students. It's always been about the students. It's always been about creating opportunities for people to really enter the workforce with these skills, and all of them are incredibly successful. One of the first projects I did was that really brought to bear a lot of different drone technology in kind of a coastal ecosystem focused wetlands type of project. Was a North Carolina Department of Transportation funded um, project where we looked across a really huge um, gradient of wetland types to understand how can we do better at improving how we plan around wetlands and how we predict where wetlands are and how we understand what these ecosystems are doing, how they're behaving, so that we can better steward them and better mitigate for their loss, and all of the other components. And that project involved a wide array of data sets and data types. So we used a lot of in situ data collection, ground control points, static service. I'm sorry that these are changing. Checkpoints. So a lot of GPS technology, a lot of airborne lidar and multispectral data sets collected across, like I said, a range of different wetland types. So this is spanning a long coast in a state that has a massive economy that's focused around the blue economy, that's focused around ecosystem protection. And so we did all of this work for a couple of years and collecting some really nice lidar data, multispectral data, in situ data, vegetation data, so all of the kinds of data sets coming together. And then all of that essentially got mapped out into specific maps. So this one on the left shows an example of a machine learning algorithm that created, or a set of machine learning algorithms that created a really detailed, up-to-date classification relative to some of the other state-of-the-art classifications for these coastal ecosystems. And these ecosystems are inherently difficult to classify because they are very mixed. There's a lot of tidal fluctuation. There's a lot of influence. There's intrusion of salt water. There are a lot of different processes happening that are very dynamic. So it's really hard to keep these maps and these classifications up to date. But as I said, with drones, we have a lot of trade-offs between spatial extent. We have great temporal and spatial resolution coverage, but the spatial extent can be limiting. So a lot of the other work that we've done in these coastal ecosystems that leverage drones as that gap filler is to take that drone data and use it to train up larger models, as did one of my former grad students, who is now a UAS expert in his field, Patrick Connell. And so we took all of that drone data and extrapolated out to larger and larger regions so that we can create these up-to-date classifications and to bring the wealth of drone technology and drone data to bear to extrapolate and get a sense for how our coastal ecosystems are doing at larger scales. And as we were doing a lot of this work and a lot of this data collection involving topographic LiDAR, so near-infrared type LiDAR technology, in these coastal ecosystems, one of the big things we ran into was that it's really hard to get a return, right, from a near-infrared LiDAR over water. And these ecosystems are primarily water. And it is so important for some of the assessments that need to be done by state and industry partners to understand things like the proportion of marsh relative to the tidal datum. So how much of my marsh is below the mean high water versus above? So teasing out some of that dynamic water-land interface is really important. And that led me to essentially identifying a gap in what we were doing with drones and thinking about green band LiDARs and topobathymetric types of technologies. And that led to essentially last year being awarded a major research instrumentation grant at my old institution, UNCW, from the National Science Foundation to establish a coastal UAS observatory for coastal mapping, because coastal mapping, these transitional land water zones, are difficult to map. They are extremely dynamic. They change on timescales that are really small. So we added a lot of different sensors into the mix of what we were already doing, and specifically started exploring topobathymetric technologies. And one of those topobathymetric technologies that we are exploring in understanding these dynamic ecosystems, in mapping them and in modeling them, are UAS sonar-based bathymetry, in addition to LiDAR-based bathymetry. And here are some examples from the single beam sonar data we've collected back in North Carolina that we're going to continue to do experimental work with, to really get at these really fine scale models of bathymetry, but shallow water bathymetry, where we can't get your normal more heavy duty bathymetric technology to work as well. So there are a lot of gaps along all of our developed coasts in that in between shallow, tidally influenced bathymetric area that we are hoping to make headways into mapping and understanding better with some of this technology. And as I've been doing all of this stuff and really passionate about training our next generation geospatial and UAS workforce, I have recently joined Mississippi State University, which is actually the lead institution in an alliance of 29 universities within the United States, as well as about 100 industry partners, that is focused on the safe integration of UASs into the national airspace. So with the team at Mississippi State, we are really working hard on bringing in and really thinking about all the different ways that the UAS potential can help us not only advance what we do in research and academic research, and what we do in solving some of these problems along the lines of training and cybersecurity, disaster response, e-commerce, but also really credentialing and thinking about how to align these academic offerings and the really cool cutting edge research we do with what is needed in the workforce in the next 5 to 10 to 20 years. So if you didn't know, Mississippi State has this really awesome resource. It's called the Raspet Flight Research Lab. Some of the largest drones that any institution has, and we are primed for adding some really cool sensor technology and testing out some of these really amazing sensors and technologies that SPH Engineering and others are coming up with. So come talk to us if this is something you're interested in. So I'll wrap it up by saying that all of the research that I talked about a little bit plays into this larger umbrella of the blue economy. And I'm sure everybody's heard of the blue economy. And in the past, it was called ocean economy, and then it was called kind of blue economy focus. And the blue economy is focused around the promotion of the economic growth, social inclusion, and improvement of lives and livelihoods in coastal areas, right? That's what I started with. Well, this new blue economy that if you talk to folks at NOAA and beyond, is focused on really how do we use the incredible wealth of technology and data and information that we're collecting from all of these remote, underwater, aerial, various types of sensors. We're collecting this data all day long, but how do we use it to catalyze public and private sector innovation and make smart decisions about that will actually allow us to have longevity in our coastal areas. So all of the stuff we're talking about really can help us improve the economic and social outcomes of half of the world's population if we do it right. And I think I'll stop there and like to take questions.
Thank you, Narcisa. Very great presentation. And now I know a lot about all this coastal environment and new blue economy. And let me be the first one who asks your question. You've mentioned it already that you use a lot of different methods to study these environments, but how do you combine them? I mean, all these traditional methods and new technologies, and maybe any life hacks or any tips and tricks on how to get the best efficiency out of all these methods?
I think the key to that is having, well, for example, I combine a lot of in situ data collection. So it can be vegetation transects, it can be vegetation quadrats, it can be, that kind of, or just the more standard wetland delineation that you'd come across. So I think the key in combining all of these is to have first of all the right people at the table, and to really think about if you do in situ data collection, what exactly do you need to then be able to match that up into your imagery collection, into your data collection from a drone platform, and how exactly then what you get from these two sources match up to maybe your higher level of integration. Because like I said, for me, it's always about how to take the data that I collect with a drone or on the ground and really extrapolate it or expand it over a larger area. So aside from bringing in the right collaborators and having the right people at the table, I think it's important to have a plan and to know what the minimum requirements of the data that you need from each source is to go into the ultimate goal. And the ultimate goal really is, if we make a wetlands prediction model that informs how the Department of Transportation, for example, allocates their resources on wetland mitigation credits, that is a decision-making tool. So it's all a matter of how we take the individual pieces and make it a useful decision-making tool. Or that's the kind of research I do anyways. It's very applied.
Yeah. Thank you. And the second question, quite close to it, also all this coastal ecosystem are really delicate and really fragile. What should you take into account when using all these drones or sensors or any other method for in situ data collection, just not to harm to the ecosystem,
Sure.
not to make any.
And I think, yeah, and I think I said that a little bit in the very beginning. That's why that's exactly why I got into drones for these wetland ecosystems, because they are inherently, and not only, there are other types of ecosystems that are incredibly sensitive that don't necessarily do well with human interference, especially if the goal is to ultimately keep them intact and allow them some level of protection. So I think the key there is to be strategic about how you choose your operating area, how you choose your launch spot, how you kind of, again, it's all about being strategic in accessing or being nearby, but not necessarily right within. So it's not a one size fit all. There are multiple nuances that need to be met. But I think drones are an incredible tool for collecting data in ecosystems that are intrinsically sensitive and difficult to access. But then again, they present other types of option accessibility issues, because then if you put a big, nice, a very expensive sensor over a heavily forested wetland that you don't have a good way to have visual observers in, I mean, that there's a lot of other types of issues that you're going to run into. So that's why also it is important to be able to tie what you can get with UAS technology into other types of data, so that you can expand your footprint.
Right. Okay, thank you. Yeah, I believe we will discuss it in the second part after we have all these presentations and open discussion. And please, dear attendees, please leave your questions. We will certainly answer all them after the Peter's presentation. Peter, I believe that's your turn now.
Yes, hello everyone, and thank you very much, Alexey and SPH Engineering for the invitation to join this interesting webinar. I'm Peter Bauer-Gottwein. I'm a professor in hydrology and water resources at the Technical University of Denmark. And about a year ago, we got a large project funded from the European Union through this Horizon funding program, which is titled Unmanned Airborne Water Observing System, right? So the idea in this project is to develop, to commercialize, and to apply new methods, new drone-borne methods to observe rivers and surface waters. And actually, SPH Engineering is one of the partners in this project. And I guess that's why I'm here today to talk about it. So I invite all of you to have a look at our website here, uawas.dtu.dk, where you can find a lot more details and also the relevant contacts and the partners, etc. Now, what is this project really about? Our vision is basically summarized in these 5 bullets here, right? So we want to develop new payloads, radar altimetry for water surface elevation, Doppler radar for water velocimetry to get the surface speed of the flow, sonar and water penetrating radar for bathymetry. We want to go beyond just the payload development and also look into how can we actually effectively and cost effectively and efficiently deploy these payloads over the relevant scales, right? So for instance, water surface elevation, if you think of a river, maybe we want to observe some backwater effects or some water level profiles in high flow situations. We would typically need to do that over a scale of a couple of tens of kilometers, right? So and what is needed in order to get there? What kind of drones do we need? What kind of deployment techniques, what kind of resources do we need to do this cost effectively, both for the water surface elevation, the bathymetry, and also the flow velocity and discharge? Then the third kind of direction is to combine these drone data with satellite Earth observation. For instance, there's this big global record of water level time series, which we get for free from the satellite altimetry missions like JSON, like Sentinel-3, Sentinel-6, and others. And those spaceborne missions, they provide water level time series at thousands of places around the world. And if we find a way to kind of turn those water level time series into discharge time series using the drone techniques, then I think we can make a major contribution to water resources management. And then we want to demonstrate the value of all those new data sets in various case studies around the world, and kind of try to establish this drone hydrometry, I call it UAS hydrometry, right? Looking at rivers using drones, to establish that as some kind of the new normal in this area for monitoring rivers and surface waters. Now, just to summarize what is the purpose, right? So water surface elevation, this is a little simplified graphic to show you what we have in mind, right? So the river flows along its course, and depending on the bathymetry and depending on, for instance, vegetation growth in the river or tributary junctions and backwater effects from the tributaries, etc., you will see these kind of spatially variable water surface slopes and steeper portions and less steep portions. And so far, people just have data from a few stations scattered along such a river, but with the drone, we could just fly along that river and really get the full profile, high resolution at sub-meter resolution, see how this water level really behaves in space and how it changes in a high flow situation versus a low flow situation, for instance. So that's the water surface elevation workflow. Then the riverbed geometry workflow, which is similar to the things that Narcisa has also talked about. Try to combine LiDAR with water penetrating radar and sonar technology to get the full riverbed geometry, right? Unlike the coastal environments, rivers are typically quite turbid. So green LiDAR is a kind of a challenge in many places, and we see some good potential there for water penetrating radar and also sonar, right? So the bathymetry problem is really a hard one, which in rivers is a very hard one, which we have been struggling with for a long time. And there's probably no silver bullet, no technology that can do it in all circumstances. But we believe that water penetrating radar can play a good role here. And then finally, the water velocimetry, right? To try to get surface water speed from a Doppler radar in this case. There are all these techniques using optical techniques, image crop correlation techniques, which work fine in, let's say, smaller rivers with lots of features and lots of things that you can track. But for large rivers, we believe that the Doppler radar is the right tool, because you don't need to have the entire river in one scene, and you can actually fly over, do these waypoints, and get a velocity cross section at the relevant scale. So I'm just to kind of start the discussion. I want to show a few first results from one of our first surveys here, where the focus was on payload validation, right? So trying to see how these new payloads actually perform compared to in situ technology. That was done a couple of months ago in southern Sweden in a river called Rönneå, which is actually not a big river, a rather small one. And we deployed all kinds of different sensors here. They're listed here. Different in situ sensors, also different legacy payloads that we had at DTU, and then the 4 new ones which are kind of being developed and being tested and being further developed in this project, right? So this is a water surface elevation payload, a SPH sonar payload, which you also see flying over here in the left panel, and the water penetrating radar and the Doppler radar. And here, just a few results, right? So here you see an aerial view of one of these cross sections. You see the flow in the river. You see the vegetation in some areas, right? So that's a typical problem in these lowland rivers, that sometimes the water column is quite densely vegetated. And over here is the corresponding cross section. In this case, with the water penetrating radar. So this is a 150 megahertz version of the radar, and you see that it really nicely picks up the bathymetry and all these different smaller features. So it seems quite reliable in this case. Also, when you compare it to the sonar, which is on the next page here, right? So this is the sonar technique. And one thing you clearly see here, right, if you compare it to the water penetrating radar on the last page, is this vegetation influence, right? So the the sonar is always sensitive to submerged vegetation, and when you get into these situations, you typically have problems picking up the river bottom. So in this particular setting here with vegetation and quite turbid rivers, right, probably the water penetrating radar is one of the best things you can do. And then finally here, a little teaser on the Doppler radar. This is the thing that is still most, let's say, in a development stage. It's not yet mature, but I think the first results we are getting, they look quite promising, right? So you have the ground truth from an electromagnetic velocity meter here. That's the red stars. And then we have different estimates from different waypoints along cross-section from our Doppler radar, also at different flight altitudes. And yes, there's still quite a bit of noise on this. That processing has to be further developed, etc. But we can already see now that the magnitude and the shape of the velocity profile is actually picked up quite nicely, except for this portion here to the right-hand portion of the cross-section, where obviously we have all this vegetation, and that confuses the Doppler signal and don't get any useful data over here. But overall, I think to summarize, our first results look quite nice, and I think that is from a scientific point of view, that is great fun to do, right? So you can go out with these new payloads, you can try to understand the physics, how it interacts with the flow, and compare it to established technology, and then learn how to do these things, and then push it forward and develop it into some effective and cost competitive large-scale monitoring workflows. I think that's what I have to get the discussion going. So thank you very much.
Yeah, thank you, Peter. Thank you so much. Basically, I have the same question to you as I had to Narcisa. You have all these different payloads and traditional methods, and like, how do you combine them? How do you understand what should be used for this, I know, research or for that research? And what is your tips and tricks on choosing the right technology?
I mean, in terms of combining in situ and drone stuff, right? I think the typical workflow would be you deploy them jointly in some cases to understand the limitations, the accuracy, the performance of your airborne technique. And then, of course, ultimately, the goal is to try to avoid having to do the in situ data collection, right? So, for instance, here with this river cross-section surveys, I mean, the operational departments, guys like SMHI, they have to do this every couple of years, right, to keep track of the river shape to avoid flood risk and all that. And that's a significant cost factor. I know Denmark spends around 200 million Danish kroner. That is roughly something like 20-30 million US dollars. And Denmark is a small country. So it's quite significant money that is spent surveying rivers, right? And of course, if you can try to do that more effectively and save costs, that is a big price. So, and then the other thing you can think about is combination of satellite EO and drones, right? And that is also part of our project here. I think what is good with the satellites is that you have this automatic orbit repeat, right? So you get data basically once the satellite is up there, you get data continuously at given temporal resolution, but you don't need to go out and make new surveys all the time, right? So this temporal aspect and monitoring the dynamics, that is actually quite nicely done with satellite EO, while the drones have this high spatial resolution and can give us details and data sets that we are unable to get from satellite EO so far, right? So trying to mesh these two things together, enhancing the value of satellite EO with targeted drone surveys, I think that is also a promising avenue in many ways. And yeah, one of the examples we have in the project here is this virtual stations from radar altimetry and how to turn them into actual discharge stations.
Yeah, that's good. But you've mentioned cost savings and like efficiency improvement. Can you share any at least preliminary results? I mean, or insights in terms of drones efficiency and how it can help to save time and money?
Yes, I can't give you a number, right? But what we typically
Maybe
see in
your estimates or feeling.
yeah. What we typically see is something like a factor 2 to 3, right? In this river work, right? So I'm always talking about the hydrometric work with drones, comparing that to in situ work using boats or wading through the river, right? So for instance, the estimate that the industry here in Denmark has to survey a cross section like what you see on the screen right now. This is about 20 meters wide, about 2-3 meters deep, so too deep to go through, wade through. They estimate that this costs about $1,000 per cross section, right? So doing a survey like what you see on this slide here with a reasonable spatial resolution, something like this, that would come with a cost tag of about $1,000. And if you think about it, if you plan a survey carefully, right, you have to do this every 100 meters along the river. It's quite clear that at least the field operations will be a lot more efficient with the drone, right? So I would say factor 2 to 3, but then you have a larger overhead on the data processing side. And that's when all these issues come in, like vegetation, right? So what do you do if you have a lot of vegetation in the river? Can you find some kind of automatic workflow to clean your result from these vegetation effects or not, right? And that will then determine the processing time that you invest.
But yeah, still to the order magnitude of 2 or 3. That's a lot. Narcisa, what about your experience in your projects?
I was going to add that was definitely the impetus for some of the work that I started doing with the Department of Transportation in North Carolina, and they were estimating that, I mean, they told us that they were spending anywhere from $120 to $180 per acre of to do wetland delineation on the ground, and it would take anywhere from 2 to 3 weeks to do basically a relatively small 2,000 acre site. So that's about 800 hectares. So multiple weeks, multiple people, $120 to $180 per hectare with a team on the ground. And that's exactly why they are looking and they are incorporating drones into their workflow, because it is a significant cost saving. Even if you add in the data processing and if you add in the implementation into a machine learning model or a prediction model, it's still an incredible cost saving.
Yeah, totally right. Peter, I believe there is a question for you from Ninat. Have you tried to measure the change in flow in relation with surface runoff after the rain periods?
Yeah, we have a paper actually I think it was in 21 or so in Water Resources Research, where we show different one possible workflow to estimate river discharge purely drone borne, right? So the challenge here is you have to combine the bathymetry and the surface velocimetry, and then you have to take some assumptions about how the bulk velocity depends on that, right? So because so far we have no technology to really get the full velocity profile throughout the flow cross section. So we estimate the bulk velocity from the surface velocity only, and we inject the water surface slope into that estimation, right? So that helps quite a bit, because the water surface slope tells you the energy loss of the flow, and so you get a control on the Manning number or the hydraulic roughness, and putting all that together, right? So the observed slope, and remember, this river slopes are very, very mild, right? So you may think, oh, I just go 100 meters upstream, 100 meters downstream, and I take 2 GPS measurements, and then I have the slope. That is typically a problem, because the difference may only be a couple of centimeters, right? So from the drone workflow, we get many points, and we get very high resolution, and then we can do a regression and actually estimate that slope at a much higher accuracy. And with those accurate slopes and the surface velocimetry and the bathymetry, we can get reasonable discharge estimates. Of course, they are not at the same level as, for instance, ADCP. I guess a really good discharge measurement has 5% accuracy. That's what the industry tells me. 5%, that's what you need. I don't think we can, so far we can't do that with the drone, but we can be somewhere around 10-15%, I believe.
Mm-hmm. That's also good. That's also good. Okay, thank you so much. Yeah, I suggest we can continue with discussing some maybe personal or industry experience. I mean, academic world experience. Do you know about any breakthroughs or like scientific or research breakthroughs which that become I don't know, came into reality thanks to drones and drone technologies? Please, our dear listeners, you can share also your experience.
I think from my perspective, I was trained as a remote sensing scientist before drones existed, right? So it was back in the day when we actually still had to pay for Landsat data. We had to pay for one scene of what is now taken for granted, freely available Earth observation data. And for me, the big breakthrough that drones brought in was taking out a lot of some of the in situ data collection. So I have spent weeks and weeks for my PhD research in Africa, and I had a compass, I had a camera, I had a clipboard, I had a GPS, I had about 5 different things hanging around my neck, and I spent weeks going to collect essentially training data for remote sensing type analyses. That's how we used to do it. And then with drones, a few years later, we went back to the same area in Africa, but this time with drones and some multispectral cameras, and we were doing the same kind of research. But now, instead of having 7 things around my neck, we would fly these small missions, and we flew enough of these 250 by 250 meter missions, for example, and got just enough data in situ that we were able to kind of do the same type of training of our satellite imagery, but so much more efficiently. So in a way, it was remote sensing with drones is a breakthrough for the remote sensing community, because it is allowing us to explore options that they weren't even possible before within my lifetime.
Yeah, that's really
so that
interesting.
marriage of scales and the marriage of, like what Peter said, it's ultimately what we want to be able to do is have the models be so good and the data that we collect with drones so good after we do the proper validation and accuracy assessment and all of that, that we can kind of take out some of that boots on the ground, very time intensive and cost intensive data collection. So it's a breakthrough.
Yeah, that's definitely a breakthrough, and I believe that that also helps to access some terrains or some areas which were inaccessible before.
Right, absolutely, and areas that are potentially straight up dangerous. I collected data and got almost attacked by buffalo and things, elephants. I mean, you are taking out a lot of other things out of the equation too with drones potentially.
Yeah. Peter, do you have anything to add here?
Yeah, I mean, maybe I can just give one example.
Buffaloes or...
Yeah, I've also met buffaloes during fieldwork, but I actually wanted to mention something else. We had this 10 years ago or so, we had this project on the Yucatan Peninsula, and that is like a cast limestone platform with all these underground rivers, right? And many of you may have seen movies about it. It's beautiful, and one of the problems there is groundwater management, right? So because there's all this tourism activity and contamination, groundwater contamination, no one understands how the groundwater really flows in that area, and there's no monitoring network, or at the time there was no monitoring network, right? So, but at the same time, there are all these sinkholes, right? So because it's karst, there's a sinkhole basically every, I don't know, couple of kilometers. And and they're in the middle of the jungle, and of course hard to access. But with for instance, such a water surface elevation technology, you can basically fly to those sinkholes, right? Get the groundwater table elevation, and then fly to the next. And from that survey, you would be able to develop a piezometric or a groundwater table map of the peninsula, which could then inform groundwater management and tell you what the groundwater flow patterns are in this area, right? So I think this is maybe an example where you can really see, okay, this type of technology enables things that simply weren't possible before.
Yeah, thank you, Peter. Thank you, Narcisa. And there is a question from Georgievich. Have you had any personal experience related to flood management conducted by drones? And I believe, Peter, that's your topic.
Yes, flood management. I think the closest I can get towards that is maybe flood mapping, right? Because I think flood management is a lot about flood models, right? So people try to build flood models that would predict how the flooding will look like for certain extreme events. However, these models need to be calibrated, and you calibrate them by comparing a flood prediction with an actual flood map that you collect using some technology. Now, I think for the more large-scale flooding problems, satellite EO is the way to go, right? There's SAR imagery, there's also spectral imagery, which you can process into flooding maps, and that there's several global scale data sets, and there's a lot around that one can use. However, in Denmark, for instance, flooding will be at a scale that is much smaller than what you can see from a satellite, right? So our flooding problems here with these smaller rivers, they would be subscale for the current Earth observation technology, satellite-based Earth observation technology. So that's where drones, for instance, can play a good role, because, for instance, with the thermal camera, you can quite reliably map inundated areas, and then those inundation patterns, right, you can hold them up against the flood prediction that comes from the models, and then either improve the models or calibrate them, or maybe also discard them if they're too bad.
Thank you, Peter. Yeah, I have a question to you and to our audience. We discussed that drones are great gap filler, and they allow to save like by the magnitude of 2 or 3 all our time and money and everything we need for research, and that allows us to access inaccessible areas. But as far as I know, as far as we know, there are not so many universities or research centers who are using drones that extensively. And that's why I have this short poll for everyone about what is the main obstacle to using drones in research. And if you have any other ideas what stops universities and research centers from using drones, please add it to Q&A section. I can't believe we can stop here. So I hope you can see the voting results. And as I said, the most popular top three, I would say, the first one is lack of information, like educational programs and resources. Second thing, that's too expensive. And the third thing is too complicated to get grants. And I believe we should discuss it. And let's go one by one. Lack of information and all of this education. Narcisa, you've done a lot, and you are doing a lot for educational programs. Please share your experience and your vision on what we can do as an industry to improve this.
I think what you're doing right now is a great. I mean, it's really interesting that is the top. That's the top thing that emerged, right? Because it's probably why we're sitting here doing this today, and why I'm also very passionate about talking about the role of drones. But but think about it in terms of how do we use them for very applied projects to really meet needs and to really respond to a gap or to existing demand, and then to get people out there to talk about how they are using and how they're building a career, and they're building essentially a research program around using this technology. And I think in the United States, I can say for sure, when I started talking about buying my first drone in 2015, the word drone was not well received, right? They had some negative connotations for reasons that we probably remember around that time frame. So a lot of it has been just shifting people's mindset on drones for good. The drones as a neutral technology, it's not a bad technology, it's a technology that can be used to solve problems and to maximize how we reach people and how we even get people into STEM. I didn't even show, but I have photos going and demonstrating drone data collection at elementary schools, and those kids are just in love. And then a fact that in exposing kindergartners through high school people to drone technologies and the potential career opportunities they have, I think it goes a long way. So that all adds up together. And then to the other points, they're too expensive and they're too complicated to get grants, and that's exactly why. Yes, I mean it's a little bit of a barrier to entry in a way, and that's, I also didn't say this, but I entered into this drone world with a $1,500 drone, right? That's all it was, a $1,500 drone. I jerry-rigged a $3,000 camera on it, and we just went out there. So it's like small pockets of money. You start off, especially if you have a need, and I had a specific need I wanted to meet. So you start off with something small, you do it, and then you show that, hey, it's meeting my needs, it's able to do XYZ for me, get something published, get some students, and then that's what led to the next thing, and the next thing leads to the next thing. So I think starting small is good, and getting students and getting folks involved early, those would be really critical, in my opinion, components to bypassing these barriers.
Okay, thank you. Yeah, I believe that these recommendations of yours, they are applicable to every new area of everything. Start small, show results, show success, and you'll be fine. Peter, what would you say? What would you add about these three major concerns or obstacles?
Yes, I think I think it depends a little bit what we are talking about, right? I mean, if it's this more standard established surveys, LiDAR, photogrammetry, whatever, which are mature and commercially available and off the shelf, I think it's probably, if anything, it's a matter of cost because it's easy to do and it provides beautiful results and all that. Now, if you're going more into the development of new stuff and near surface flights and all that, for instance, the water penetrating radar, you fly at, I don't know, 0.5 meter above the water surface, it needs quite skillful and experienced pilots, right? And it's not something that we typically have at the university. I mean, I ended up working with a private survey company because also, I mean, yes, it's good to train students, but they move on, and I mean, then they've learned all the stuff, and then they're gone again, right? So I mean, having the skill long term at the university to do these things is not easy, I believe, and it's not a standard. And a standard lab technician or field technician at the university would not have those skills. So I think that's maybe part of the problem at the moment, particularly at the university, that it is still a little bit of a niche skill set, something that not everyone has, and it's not so easy to get access to that type of skill, I believe.
Thank you. But at the same time, I believe that's a great business opportunity for drone service providers. And I know that there are a lot of drone service providers who are listening to us. So guys, if you are looking for a new business niche to work on, please go, work with universities. They have a lot of advanced things to do. Okay. Pat Clark mentioned in the comments that there are regulations which are bearing use of some drone manufacturers. Okay, we all know about this blue list and green list, but I would expand this question. Are there any specific regulations for using drones for research, or all they have is just the same industry-wide regulations?
I'm not aware of any specific regulations when it comes to research.
Mm-hmm.
Not
so,
that I know.
So that makes things easier. All we need to do is just to buy a small drone and then get your pilot license and then go and fly and collect the data. Okay.
I would add to that there are no specific regulations, but maybe if you're depending on the type of location you're flying, you could be running into things like wildlife disturbance issues or some privacy, some data collection areas that are off limits. So I mean, there are a few types of regulations that could potentially only apply if you're doing research type projects. Specifically, wildlife disturbance has been a big issue for the kinds of ecosystems that I work with, and having to be able to show that you are not impacting short nesting birds or things like that if you're doing your surveys. So depends on the location.
Thank you, Narcisa. There are a couple of questions from our listeners. First one from Hezri. I see there is a river cross-section data. I believe, Peter, that's for you, and this question is for you. Is this data updated by using a drone that carry a water penetrating radar as a payload?
Yes, absolutely. That's actually an SPH Engineering product. It is a Zond Aero ground penetrating radar.
Okay, that's good. And also a question from Long Kang. He has a concern about that is flying drone over water is not recommended, and flying drone for bathymetric survey is not efficient for large areas such as a river survey. Can you share your experience?
Why is it not recommended?
Oh, I don't know. That's all I have.
Yeah,
probably you're dropping your sensor in the water.
But we have insurance at least.
Yes, I don't see any specific reason why it should be more risky to fly over water than over land. If anything, yeah, I mean, there are some issues with the terrain following, maybe depending on what kind of altimeter you use, but other than that, I think it's fine. Now, of course, in terms of efficiency, I think it's correct. One always has to be very careful to see if it's really more efficient than, for instance, using a boat with a multi-beam or scanning sonar or something like this. We think that in rivers like the one that is here, for instance, with all the vegetation, all that, it's sometimes hard to get through by boat, right? So I think it's this intermediate scale where the rivers are not easily navigable by boat, but they're too deep to wade through. I think that is the segment where airborne surveying really has some advantages.
And likewise in coastal systems, exactly what I was saying. There's that in between the really shallow tidal influenced areas. And I do agree that it is, I mean, from somebody who's flown a drone over water, I think it's more nerve-wracking to do bathymetric surveys than it is to fly over land. I don't know about you, Peter, but I find it way more nerve-wracking. It's not the same.
Yes, so as I said, fortunately enough, I didn't have to do these flights myself because I had this very good pilot. But you can see here the water penetrating radar on the right hand video here. It's really close to the water, and closer you go, the better your data, right? So there's also some incentive to get quite close. But for him, he said it was not really an issue. He was quite comfortable flying this mission.
I flew a bathymetric LiDAR over water, and multiple issues, but one of the main issues was that the reflectivity of the water was throwing off the laser altimeter, and there are a lot of. And then
yeah, but I think if you use a radar altimeter, you will have much less problems of
indeed,
that type.
Definitely.
Yes.
Okay, it's time for us to wrap up. And before we wrap up, I would like to ask you the last question for today. One, but the most meaningful advice to your colleagues from the industries on how to start with drone adoption. Okay, I believe that Narcisa has answered already to it, but maybe some your personal advice.
How to get
what
started?
Would be advice to, how to get started? What would be your advice, especially in hydrology and all this water-related research?
Yes, I think the key is, at least when it comes to success in research, I think the key is always to have a good question, right, or a good application, or something where you can really see that the drone would make a difference, right? And I mean, it's not always so obvious where exactly the added value is, and I think it needs some careful thinking in terms of the spatial coverage, the temporal resolution, right? Because doing repeat surveys with the drone is really not very efficient, right? So if you're primarily interested in dynamic phenomena and changes over time, I think maybe an online sensor or something like that would be maybe do a better job. So the drone is always good when it's about spatial variation and patterns and things where one snapshot really can give you a lot of extra information and insight.
Yeah, that's a great insight. Thank you. And Narcisa, you wanted to add something?
Yes, I would love to provide something, and especially if you're trying to get started with something. I got started with very little money, small, like I said, and I taught myself. I just experimented and tried this and crashed the first fixed wing into a tree and did it again. So my advice would be if you get started, get some good training. The second time when I got some of these more expensive sensors with that coastal UAS observatory, I got people like Frontier Precision to come down and train us, and that made all the difference. So getting some good upfront training to know exactly what your sensor is capable of and what you're able to do and not to do, it can get you up and going so much faster, and that curve, the learning curve, so much lower. So that would be my best advice. Definitely invest in a little bit of training.
Thank you again, everyone. Thank you, Narcisa. Thank you, Peter.
Thank you very much.
Thank you.
Great insights and a lot of great information. Thank you again for your time, and hope to see you again soon.
Yeah, see you.
Thank you.
Thank you.
Thank you.
Great day, everybody.